Okay, today we're going to be talking about predicting charges for atoms when they gain or lose electrons. So let's go ahead and start. This should be page 2, sorry, not page 4. And we're going to talk about what gives ionic bonds their properties. And ionic bonds are made of ions. So here we see the sodium ion has a charge and a chloride ion, and it's making sodium chloride. And so an ion's definition is an atom that has gained or lost electrons. And remember, they do this in order to gain stability. So this is what we're going to look at today. Questions 5, 6, 7, and 8. So as a reminder, the octet rule, all atoms are most stable with 8 valence electrons. If they can get that, sometimes they don't. So how many valence electrons are in an atom of sodium? So here's sodium. And we want to look at our outermost electron here, which is right here. So we've got 1 valence electron of sodium. And so sodium has 2 options. It can either lose this 1 valence electron. And when it does that, you get rid of this energy level right here. The next energy level down is completely full with 8. So that's one option that we can do, is to have it lose 1 electron. Another option that we can do is for it to gain 7. So if we add 7 more, now this outer shell has 8 total electrons. So electrons do a lot of times what people do. We want to do the easiest thing, or the thing that takes the least amount of energy. So what takes the least amount of energy? Losing 1 electron or gaining 7. You're correct. It's to lose 1 electron. So when we lose this electron, here is what happens. Let me go ahead and click through this. Okay, so here's our options. Lose 1 electron or gain 7 more electrons. So sodium's going to lose the 1 because it takes the least amount of energy. So let's take a look at what happens here. If we have a normal atom of sodium, I want to look at the protons and the electrons. We have 11 protons of sodium. And if it's neutral, we have 11 electrons. Well, what's happening here is we're losing this electron. So sodium will still have 11 protons, because if it doesn't, it's not sodium anymore. But now we're getting rid of this 1 electron, so now we have 10 electrons. So if we have 11 positive protons and 10 negatively charged electrons, our overall charge is a +1. So this right here, when we lose an electron, makes sodium, okay, with a +1 charge. And when we do that, it's making sodium very stable because we've lost this outer electron right here. Okay, so now we're going to predict some items for the next little while. Okay, so potassium. Let's talk about how to get potassium stable, just like we did with the sodium. So right here, we're seeing that potassium has 1 valence electron. And you can also look, remember, at the valence electrons according to where they're placed on the periodic table. So for example, group 1 has 1 valence electron, group 2 has 2. Over here, 3, 4, 5, 6, 7, and 8. Remember that helium only has 2, but the rest of these have 8. So you can also look at that. Okay, so potassium has the same scenario as sodium. It can lose 1 electron, or it can gain 7. So I want you to think which one would take less energy. You're correct, losing 1. So when we lose 1 electron, we're losing that negative charge, because remember, electrons are negative. So we're going to have potassium with a +1 charge. Okay, and that's its ion. It's going to be stable if it loses 1 electron. Let's go to the next one. Okay, let's do beryllium. So beryllium, and you can go ahead and pause the video at any time and then come back and see if you're understanding this on your own. So beryllium right here, it has 2 valence electrons. So here it is in the periodic table. It's got 2 valence electrons, and you can also see right here we have 1, 2. So beryllium has two options as well. It can lose 2 electrons, okay, or it can gain 6, because if we gain 6, 6 plus these 2 equals 8. So again, think about what would take the less amount of energy or the least amount of energy. That's going to be your 2. So if we lose 2 electrons, it's going to be Be with a 2 positive charge. So let's just break that down and look at that and make sure you feel okay about that. So beryllium right here has 4 protons and 4 electrons, and that's as an atom. If we look at losing 2 electrons, it's going to be right there, 2 electrons. So the difference here is going to be a +2 charge. And that's where we're getting that charge right there. Okay, next one is gallium. So here is gallium on the periodic table. Notice it's in group 13. So remember, we cover up that 1 and we have 3 valence electrons. Also over here, 1, 2, 3. Okay, so again, what happens? We can lose 3 electrons, or we can gain 5, because 5 plus 3 makes 8. So what takes the least amount of energy? Losing it. So this one, gallium, would have a 3+ charge. That's supposed to be a nice G. Okay, which just means it's lost 3 electrons to become more stable. Okay, carbon. Okay, here's our carbon. It's right here. So carbon can either gain 4 electrons because it has 1, 2, 3, 4 valence, or it can lose 4 electrons. So carbon can go either way. It can either be a +4 if we lose 4, or it could be a carbon with a 4 negative if it gains 4 electrons. Because if you gain electrons again, remember electrons are negative, and so it's going to become more negative, your charges. All right, let's look at the next one. Nitrogen. So here's nitrogen. Okay, it has 1, 2, 3, 4, 5 valence electrons, and it matches up because it's in group 15. So it can lose 5 electrons, or it can gain 3 electrons. So again, look at what would take the least amount of energy. The least amount of energy is going to be to gain 3 electrons this time. So it's going to do this. So let's just break this one down. Nitrogen has 7 protons, and it also has 7 electrons when it's neutral, when it's just nitrogen like this. Okay. When we're dealing with charges, excuse me, nitrogen still has 7 protons, right? But now we're going to gain 3 electrons. So 7 plus 3 is 10 electrons. So here, if we have a -10, oops, you can't really see that. If we have a -10 electrons and 7 protons, which are positive, our overall charge is going to be a -3. So this is going to become N with a 3 negative charge right there. Kind of interesting what's happening, huh? Okay, the next one is sulfur. So how many valence electrons does sulfur have? It has 1, 2, 3, 4, 5, 6, and it does match right there. So this one can either lose 6 electrons, or it can gain 2 electrons. Again, what takes the least amount of energy? Well, that's going to be gaining. If we gain 2 electrons that are negative, our charge is going to be S with a 2 negative charge. All right, next one is fluorine. So here is our fluorine right there. So based on this, we have 7 electrons. 1, 2, 3, 4, 5, 6, 7. 7 in our Bohr model as well. So fluorine can either gain 1 electron, or it can lose 7 electrons to be more stable. So again, it's going to do the easiest. It's going to gain. If it gains 1 electron, it's going to have a -1 charge. So we're just looking at what's happening again to make these atoms more stable by gaining or losing electrons. And again, when we gain or lose electrons, we're changing the charge because no longer is it neutral. We don't have the same amount of protons as electrons. So we're changing that charge. Okay, last one is argon. Here's argon. It's in group 18, so it has 8 valence electrons. And let's just double check. 1, 2, 3, 4, 5, 6, 7, and 8. So argon doesn't want any more. It already has 8. So argon is just going to stay as argon. It's not going to want to lose or gain any electrons. And that's why noble gases, you don't see a lot of substances or compounds made from noble gases because they're so stable that they don't need to bond with anything. Okay, now that you've done that, and here again is a periodic table with your valence electrons. If you want to go ahead and label your valence electrons on your periodic table, you could. So remember 1, 2, 3, 4, 5, 6, 7, 8. Helium's 2, but the rest of these are 8. If you want to go ahead and do that on the back of your packet, you can, just to remind yourself what those valence electrons are. So for example, if we were doing like calcium and we wanted to see how many valence electrons it has 2. And then it has 2 options. We can lose 2, 1, 2 to be like argon, or it could gain 1, 2, 3, 4, 5, 6 to be like krypton. So again, it's easier to lose 2. If it loses 2, calcium is going to have a 2 positive charge. Okay, so there's your ionic charges. Oh, sorry. Let me kind of go back. Okay, so based on what we just did, we can now predict ion charges. So on the back of your periodic table again, I want you to go ahead and write ionic charges on the back. Oops. And this is what you guys just figured out. You figured out that anything in group 1 wants to lose 1 electron, so it has a +1 charge. So go ahead and write this above your columns on your periodic table. Anything in group 2 wants to lose 2 electrons, 2 valence, so it's going to be a +2. These guys in the middle, they have variable charges, and we're going to talk a little bit more about those on Thursday. Actually, probably on Wednesday or Thursday. Then group 13, it wants to lose 3, so it's a +3 charge. Group 14 can be a plus or a -4. Group 15 is a -3, 16 is a -2, and 17 is a -1 because it wants to gain electrons. So what you've kind of noticed, the ones that are positive are metals, the ones that end up losing electrons, and the ones that are wanting to gain electrons are non-metals on the periodic table. Kind of interesting that it does that. Okay, so now I want you to take a minute and predict the charges on these atoms. So go ahead and pause the video and do that. Okay, we're going to come back. Now let's double check. So lithium has a +1 charge because it's in group 1. So lithium is +1. Oxygen's in group 16, so it wants to gain 2, so that's a -2 charge. Aluminum, +3 because it's in group 13, it wants to lose 3 electrons. And calcium, it's going to be a +2 because it's in group 2 and it wants to lose 2 electrons to become positive. Okay, and then let's double check questions 5, 6, 7, and 8 really quickly. So if you want to go ahead and pause the video, do 5, 6, 7, and 8, and then come back and check your work, that would be great. Okay, welcome back. Sodium, how many valence electrons is 1? Does it want to gain or lose? It wants to lose that 1, and when it does it, it's going to have a +1 charge. Okay, chlorine, it has 7 valence electrons. It's going to want to gain, because it's easier for it to gain 1 than to lose 7. And so it's going to have a -1 charge. Magnesium is in group 2, so it's going to want, it has 2 valence electrons. It's going to want to lose those 2, and so it becomes a +2. And then phosphorus, has 5 valence electrons. So these guys are going to want to gain, they're going to want to gain 3 because 3 + 5 is 8. And so this is going to give us -3 charge. All right, so if you have any questions, please let me know about that. Okay, let's really quickly talk about anions and cations. Actually, let's wait till the next video. So I will see you soon. Bye.